Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject short range wireless communication. We're going to see baseband coding. This baseband coding is a very important technique in digital communication, right? And today we're going to see the importance of baseband coding and we're going to see different formats of baseband coding. And in this video, we're going to see four different types of baseband coding, that is non-return to zero, Manchester code, biphase mark, and pulse width modulation. This is what we're going to see. And before starting with, what is baseband coding? This baseband coding can also be called as line coding. For your understanding, I can say it in a very simple way, uh, representing digital signal in various formats. That is the various ways of representing a digital signal. That is called as baseband coding. And technically speaking, it is the process of converting a binary data into a binary signal, right? You're going to convert a binary data into a digital signal, And as you can see in this diagram, these are the binary data. These are the binary data where you can see here 0, 1, 0, 0, 1, 1, 0, 1. These are the binary data, right? And this binary data is converted to a digital signal here, right? And why is that we convert signal? Because we cannot able to transmit the message directly, right? We have to convert it to a signal form and then we have to transmit it. And at the receiving side, we have to receive that signal form and then we have to decode that signal to obtain the binary data, right? So we can definitely say that technically it is the process of converting the binary data into a digital signal, right? And you got to understand the basics of this line coding, right? You got to understand what is data level, and what is signal level. Right? This is very basics of line coding. And this data level, signal level varies according to different formats, right? As I said, in non-return to zero, it will be different, and Manchester coding, it will be different, and five-way mark, it will be different, like that, right? And depending upon the application and depending upon the characteristics, right, we will choose the line coding. And very important thing is data level and signal level. When you take data level, right, data level is something, the binary data, that is here you can see the values, the binary data value. That is, if you take binary data, you have only two values, that is 0 and 1, right? So the data value here is 2 for all this Manchester coding or for all this baseband coding. You have data level as 2, right? When it comes to signal level represents the value of the signal, right? Say for example, if I am representing this as I'm going to draw a line here just for an example, right? If I'm going to draw a line here, right, I'm going to mention this as minus a and this as plus a. So if you take this particular format, just for an example, don't get confused, right? uh, Here you can see this has minus a and also plus a, right? So this is plus voltage and this is minus voltage. So here the signal level is A and minus A. You have two signal levels, right? Whereas if you take this particular format, right, bipolar AMI, if you take this particular format, you can see it is having 0, you're having plus A, and also you're having minus A. So the signal level is 3 here, right? Now you understand what is data level and signal level, right? So depending upon the characteristics of data level, signal level, and you have other characteristics as well, time, synchronization, DC component values, and the error detection capabilities. Based upon all these things, the line coding technique can be selected, right? And these characteristics varies from one line code to the other, right? In next video, I'll explain you about the characteristics of line coding and what are the important characteristics, how is the line coding is chosen according to that characteristics, right? And as if now you understand what is baseband coding, right? And what is the importance of baseband coding, what is data level and what is signal level, right? With this basics, we will see the different baseband codings one by one. right? First, we'll start with non-return to zero. And what is non-return to zero, right? This non-return to zero is very familiar in digital signals, right? And we will see this characteristics for a little later, but we will see the format now. What is NRZ, non-return to zero? It is called as non-return to zero. And there is something called RZ. There is something called RZ format. You are not studying here in short range communication, but in digital communication, you have this technique which is RZ, right? NRZ is something where if a digital signal, if a digital uh, signal transmit, that is travels to a different voltage level without coming to this zero, without coming to this zero level, right? Or zero voltage. That is called as non-return to zero. Say for example, this is 1 and this is 0 and this is 1, right? Here, only at 0, right, it come to this particular level. It travels in this line. It is not traveling in between the bits, right? If it is not traveling to the voltage level, zero level, if it is not coming to the zero level in between the bits, right? Then that is called as NRZ, right? And what is RZ? If it returns to zero in the middle of the bit, say for example, like this, we will see different codes so that you can understand what I'm saying, right? For example, in one code, you will represent one like this. You'll have full amplitude and full time period. And in some code, you will represent like this. You will not get into full time period. You will have only half a time period and it will return to zero again, right? And here you can see here in between the bit it is returning to zero, right? And that is why it is called as return to zero, whereas this is called as non-return to zero. Unless or until if the data is zero, right, it will not travel in the zero line, right? That is called as NRZ. Now coming to this NRZ format, right? You have one particular condition. That is, you have only you'll have amplitude level for one, and you don't have amplitude level for zero, right? That is the rules or that is the characteristics of non-return to zero. If you take one, you can see here, here it is one, so I have voltage level, right? And zero, there is no voltage level, and for one, I have voltage level, and again one, I have voltage level, and there is zero, no voltage level, no voltage level, no voltage level, and then I have amplitude level one, right? So this form is called as non-return to zero. For zero, it will return to zero, right? And if not, it will not return to zero, right? And coming to the characteristics, as I said, it is the most familiar code in digital circuitry. Serial wired short distance communications links like RS-232 uses this particular communication, this particular coding. And it is it is rarely used in wireless communication. And strings of ones and zeros leave it without defined boundaries. And DC level is very dependent on the message content. You can see there is no transition here, right? You have only one condition, that is for one you have a voltage level and for zero you don't have voltage level. So there is no without defined boundaries, and DC level is very dependent on the message content, and there is no error detection capability here, right? That is one drawback. You don't have error detection capability in NRZ, right? And we'll see the second one. The second one is Manchester coding. This is a very famous coding where you have understand one particular rule here, right? Remember, for one, you will have a transition from positive to negative, and for zero, you will have from negative to positive. First, we will see the format and then we will see the features, right? Remember this, for one, you will have positive to negative, and for zero, you will have from negative to positive. So you can see here for one, it starts from positive to negative, and for 0 it starts from negative to positive, and again 1 positive to negative, and here it's again 1, so I have to start from positive to negative, so I'm going back here, right? So it starts from positive to negative, and for 0 again it's from negative to positive, so I'm traveling here negative to positive, and again it's 0, so I have to travel from negative to positive, so I'm coming back here, so it is from negative to positive, and again it's 0, so I'm coming down, so it's negative to positive, and again it's 1, so it's positive to negative. So very simple, just understand this. For 1 there will be a transition from positive to negative, and for 0 you'll have transition from negative to positive. Coming to features, it has relatively low probability of error compared to others, and it is used in Ethernet local area networks. It has good timing information. There is always a transition in the middle of a bit, right, which is decoded as 0, and if there is a positive transition, and one otherwise, right? That is, it speaks about this transition, right? There is always a transition in the middle of a bit, which is decoded as 0, right? And if there is a positive transition and one otherwise. And the Manchester code has a constant DC component, right? And inverting the Manchester code turns zeros and ones. That is, I said, uh, like this inverting, that is polarity independent. We speak about polarity independent, but here the polarity independent is poor. That is, if you change to 0 to 1 and 1 to 0, then it converts ones to zeros and zeros to 1. That is, if you convert, if you're going to invert this particular waveform, then the data is also inverted. That is the meaning, right? The frequency response of Manchester coding has components twice that of the NRZ. So a low pass filter in the receiver must have a cutoff frequency twice as that of the NRZ with the same beta rate, right? So frequency response is twice that of the NRZ code. All these are features of Manchester coding, right? And now we will see the third one, which is biphase mark. And if I say biphase mark, right, you got to understand one particular rule, that is for one you will have a transition in the middle, you will have transition in the middle, and for 0 there is no middle transmission, middle transition. There is no middle transition, right? And another important thing, very common rule, for any particular data, either 0 or 1, you will have transition at the beginning. You will have the transition at the beginning. This is the rule. This is bit complex. Please understand carefully. For any bit, it starts with 0 or 1, right? You will have a transition at the starting of the bit. And for 1, you will have second transition, that is in the middle of the bit. For 0, you will not have any transition, right? Now coming here, coming to the data, 1 0 1 1 triple 0 1. Now how will I say that? For 1, say for example, you're going to start from here, right? So start from here, there is a transition in the beginning, right? And that is, you will start from here, that is, you have a transition in the middle of the bit, right? And it ends here, right? So we are starting from the middle here, and there is a transition in the middle, right? And it ends here. And what is 0? For every bit, you will have a transition, as I said, right? So the second bit starts, so there will be a transition up to down. And for 0, there is no middle transition, so it goes here. And for 1, that is for next bit, you will have a starting transition. And for 1, there will be a middle transition as well, so it comes down here, right? And again, there is a transition at the starting of the bit, right? And for 1, you will have a middle transition, and for 0 you will have only the first transition, no middle transition. So and again 0, so you have only first transition, there is no second transition, and again it's 0, so you have only first transition, no middle transition. And for next bit it is 1, so you'll have first transition and then you'll have second transition. Understand it very clearly. For 1 you will have true transition, right? And for 0 you will have only one transition at the starting of the bit, right? So you can see here, it starts here from the middle transition, right? And then from second bit, what happens? There will be a transition, and there is no transition for 0. And again 1, there is a transition and a middle transition. Like that it continues, right? And coming to characteristics, this is somewhat similar to Manchester coding, but there is difference. But it is predominantly similar to Manchester coding, right? Where Manchester coding will have only 2 levels. And in biphase level, whatever I said, that is what given here, right? This condition, right? You will have starting of the transition, you will have transition, starting of the bit, you will have transition, and at the middle, you will have transition for only 1, and for 0, there is no transition. The constant level has a constant DC level, no matter about the message content. And similarly, the frequency content is twice that of the NRZ, right? And biphase mark, that is biphase mark a space code. It can be also called as space code. Added advantage of being polarity independent. Even if you invert this particular code, it will remain same. That is polarity independent, right? And we will see the next one, which is pulse width modulation. This is the last technique. where in pulse width modulation, where you have one particular rule, that is for one you will have two timing duration. You will have two timing duration, and for zero you'll have only one, right? And another important thing is like biphase mark, right? It will get inverted for every transition. That is, there will be a transition at the start of each bit, right? So we will see this condition. I'll repeat this condition again. For one, you will have two time period, and for zero, you will have only one time period. And apart from it, for every bit, there will be a transition, right? Transition at the beginning, transition at the beginning, right? And now I'm going to start one. So one, we have two duration here, right? And then zero, as I said, for zero, you'll have only one duration. But apart from it, for every bit, there will be a transition. You can see here from down there is first transition, and for zero there is only one duration, and again it's one, so there will be a transition, right? And you'll have a two time period for one, right? And again it is one, so for again it is one, so there is a transition in the beginning, and it is two time period, and then it is again zero, so you'll be having only one duration, right? And only one duration here, and again it is zero. So here what will happen, you'll have a transition here, and again it will be one, only one duration, right? And then you have a zero here, and again what you will have, you'll have you'll have a transition again, right? And then for one duration, like this it continues, correct? Right? And then you have one here, and if it is one, what happens, you'll have a transition, as I said, and then you'll have two duration, right? I repeat this again so that you can understand very clearly, right? So for one, you'll have two time duration, and for zero, you'll have only one duration. And for every start of the bit, there will be a transition, like by phase mark. So here it starts from down. That is for one, you'll have two transition, and there is zero. That is one transition, and again it is one. So there will be a transition, right? And then two duration, and again it is one, so there will be a transition, again two duration, and again it is zero, so there will be transition and only one duration, and again it is zero, so there will be a transition, that is from here to here transition, and then it is only one duration, and again it is zero, so there will be transition, and again uh, only one duration, and again it is one, so it is one duration, sorry, it is two duration, right? Transition and two duration. Like this it continues. That is called as pulse width modulation. Coming to the characteristics, as I said, it has one has two timing duration, zero has pulse width of one duration. The signal level inverts with each bit. As I said, there will be a transition for each and every bit, and it also has a constant average DC level. The average pulse width varies with the message content. As I said, for one, you have two duration, and for zero, you have one duration. So the pulse width varies, and it has inherent error detection capability, right? So these are the features of pulse width modulation. So today, so far what we have seen is we have seen different line coding techniques. This is a summary of the different techniques, right? NRZ, Manchester coding, biphase mark, pulse width. You can see when you see it completely, you can see the same data, the same digital data, but it is represented in different forms. This is called as line coding, right? The different ways of representing a binary data, that is called as line coding. Or we can also say that it is a process of converting a digital data into a binary data into a digital signal, right? So today what we have seen is we have seen the very important concept of line coding. I believe this video will be very useful for you. Thank you, my dear students.